In this lecture, today we will be discussing about fans, blowers and compressors. Actually, fans, blowers and compressors, these are actually air handling devices or machineries which one will come across in many plants and industries. So, it is imperative that we understand the special characteristics of these machineries and how we can detect fault in them and what are the most common faults in them. Before I get into the details of the fault diagnosis in fans, blowers and compressors, let me just briefly give you an example as to how different they are from say other machineries, fluid handling machineries like say pumps and turbines. Basically, pumps and turbines handle fluid, it could be liquid of the sense of like water, other chemicals, but mostly when we talk about air handling devices, we talk about fans, blowers and compressors. So, the working fluid in fans, blowers and compressors is usually air or gas. See these fluid handling devices are very similar in their, I would say, principle or in their philosophy in comparison with electrical machines. So, the most common types of electrical machines are the motors and the generators, and the fluid handling devices are actually pumps and turbines. Okay. In one case, we give in work to get some increase in energy. In other case, it is that we give in or let me put it this way, we give in some energy to get some work, and here we give some mechanical energy to get an output. Okay. So, in pumps or in motors, we give some energy to get an work output, and the reverse is true in the case of turbine. We give some work to get an output. Okay. Now, coming back to this air handling devices, so we talked about fans, blowers and compressors. These fans, blowers and compressors are different in the sense that they all work with the fluid, which is air in all the cases, and we give in some extra energy from the outside, okay, to get some output out of these systems. Now, what is this output we are talking about? Basically, if you all know the Bernoulli's equation, so the energy is constant. So, we play around with the pressure head, constant, okay, and we have to play around with the pressure head or the velocity head. So, basically in fans, blowers and compressors, we try to increase the pressure at the output by giving in more energy. Pressure by mean pressure of the fluid or air in this case. Now, in many industrial applications, what are the probable industrial applications? So, if you see the industrial applications, see fans, though I have written them as mostly axial, blowers are centrifugal and compressors as axial, rotary or reciprocating, they can all be of both all the three types, but usually fans are considered to be axial, where there is no much pressure variation between the input and the output, can be taken as a fan. No significant pressure difference. So, how that is done? Basically, we have in a casing a set of blades. This is a casing, these are the blades, fan blades, and this is the hub, which is made to rotate, by an power, and then because of this either, and they are all in a casing. So, this could be axial. So, wherein I have a set of hubs, okay, and these blades are usually at an angle, and so I will slightly increase the pressure, okay, between station 1 and station 2 there will be increase in pressure, and that is essentially a fan. Now, the industrial application, the reason I am explaining you the industrial applications is we will see what are the ways these equipment or these fluid handling machineries can have a defect and how we can identify them. So, there is a very important application in this fan, particularly in power plants. See what happens in power plant, to generate steam, the boilers are given heat energy, and we get steam, and which drives a turbine, which drives an electrical generator, and we have the electrical power. And this is the, and this is in the steam cycle, the Rankine cycle. Now, the whole problem is to give this heat energy, I have to burn fuel, and in this case it is coal, pulverized coal. Okay. Now, this is burned, I will not go into details of how these are burned. Okay. Fluidized bed combustion systems are there. But so, what happens because of this burning of the coal, lot of flue gases evolve, or and they have to be expelled or exhausted, and they may be containing certain poisonous gases. So, they are actually, and they may be containing a lot of particles. So, they are actually made to go out of a very high chimney, height, and this is the chimney, okay. And the rho G H is the pressure head. So, obviously, for this height has to be maintained, because we do not want these gases to be coming out of places where they could be harmful to people. So, they have to be given a certain energy, so that they can all go out that draft height of the chimney. Now, it may so happen this exhaust gases which come we have to give some extra energy, and that is what is known as a forced draft fan, or in short FD fan. Okay. Now, this is one application of industrial fans. Same is true when we want air to come into at pressure for some combustion, and that is known as the induced draft fan. Okay. Now, similar to the fans can be centrifugal also, but I can have series of such fans in one unit, and they are usually known as blowers. The idea is to give out of the system these fluid at high pressure, okay, to a system where the fluid is required at high flow rates, high pressure, and so on. So, external mechanical energy is given to the fans and blowers, and this energy is converted to the pressure head of the fan, okay, or velocity head, depending on the application. Suppose I want to have more flow rate, more velocity, I can for the same area. Okay. This is the area. So, the flow rate is V times A. So, if I want more flow rate, I have to give in air at high velocities. Okay. Many applications require a certain volume flow rate of air in the process, particularly in blast furnaces. Okay. Blast furnaces, there are rings of tubes, okay. Okay. And air is fed in to the blast furnace around this ring, okay, at high flow rates. How can that happen? So, if I have a series of blowers in the plant, okay, and they can be all giving energy to the air, and then this air is fed to the blast furnace at a high flow rate, and this is what is done by the applications of blowers. Many a times in the air conditioning system, heating, ventilation, air conditioning systems. The reason I am telling you this is I just wanted to give you a flavor of what are the industrial applications of fans, blowers and compressors. So, we will ourselves realize what are the ways these things can go wrong. So, I would like to first introduce you to the fan, blowers and compressors, and then we will come to what are the effects and how defects are created, and then how they are diagnosed. So, HVAC systems many a place, many a times in rooms we have diffusers on the ceiling and which are connected to ducts, okay, which brings in cold air in an AC system, and these are actually fed by a blower, okay, and these are known as the AHU, air handling unit. Basically, the way the air handling unit works is, on the refrigeration system, I have a chiller, okay, on which, through which air is blown in, and by heat transfer air becomes cold, and this cold air is given into the room. So, there this calls for a blower. And again, the pressure differences are not much, be it the fans and the blowers. Okay. However, the most important or high pressure device is the compressor. Okay. In compressors, what happens? The objective is to have high pressure and as an effect, the density of fluid also increases. A good example is the turbo charger in an IC engine driven by the exhaust gases, which are used to compress in the inlet air, so that the density of inlet air increases, so that for the same given volume I can have more mass of air coming to my system for combustion. Okay. So, high pressure. Now, these compressors are basically can be of axial flow compressors, they can be rotary, the sense, or what is known as the centrifugal compressor. It will look something like this. The centrifugal compressor, there are sets of vanes, okay, and then this is the discharge, and this is known as the eye, and these are the compressor vanes, and this is the discharge. Okay. And of course, we have the reciprocating compressors. I will and then few other positive displacement compressor. I will go to the details of compressor classification maybe in the next slide. So, this is how the compressors are classified. They can be positive displacement as opposed to dynamic or turbo compressors. Positive displacements can be rotary, one rotor or sliding vane or liquid ring or single screw. And in positive displacement, basically there are lobes which look like number 8. Okay. So, these are put in a casing. Okay. And this is a lobe, rotor lobe. So, two rotors, and they move in a particular direction, and then this air gets compressed. These are positive displacement rotary compressors, and they generate, which are known as very high pressures. The advantage of such positive displacement compressors is, in small space I can very easily generate a high compressed line. In many chemical operations, chemical process applications, high pressure air is required. High pressure air, and this would call for such compressors. Of course, I just told you about the axial flow compressor and the centrifugal flow compressors, and many times these compressors have set of vanes, which are mounted on a hub, either axially, radially, and they are set at an angle. And many times in compressors we have vanes which are rotating and vanes which are stationary, which are in the casing or the stator, and they can work as guide vanes. That is, some sets of vanes are fixed, and then we have another rotor with maybe another set of vanes. So, I can have multi-stage vanes and so on, and all of these compressors are basically, again, if you are talking about dynamic compressors, they are turbo machineries. So, all the rotordynamic principles which we have studied earlier apply to such fluid handling devices. So, essentially these shafts, they could be long, which contain maybe a single set of vanes or multiple set of vanes. They have to be supported on bearings. They have to be supported on bearings, and then they can be long, they can be flexible depending on the principles of rotordynamics, and they are of course mounted in a casing, maybe with an appropriate inlet and discharge depending on the configuration. Okay. So, because they are supported on bearings, of course, this could be internal, of course. The faults could be many, and the way to identify these faults is what I will discuss next. So, in such fans, blowers and compressors, for its fault diagnosis, what are the parameters one needs to monitor? Flow rate is very, very essential, because of the fact that my primary objective was to get a high flow rate, okay, in case of the blowers, or in compressors to get high pressure. So, the flow rate measuring devices could be a mass flow meter, okay. And many times, because these compressors increase the pressure, there is also the increase in the temperature, okay. And particularly bearings, because see, some effect of this compressors operation is going to affect the auxiliary devices, particularly if the compressor is defective, the bearings may go bad. How do the bearings go bad? Because of the fact of high temperature, some of these rotors of the compressors are supported at the ends by anti-friction bearing, and these anti-friction bearings have a layer of lubricant. Okay. Now, because of high temperature, the lubricant can get baked. By baked, I mean they will burn and they will become hard deposits, and then they will form as an imperfect impurity in the races and give rise to the source of vibration. So, we have to monitor in compressors always the temperature, and temperatures are monitored by RTD, resistance temperature detectors, or even we have thermocouples permanently mounted. So, in the machinery maintenance unit, usually they monitor the temperature of these bearings of the compressors, and if there is a bearing defect in terms of the because somebody would not like the temperature, usually it is avoided. It should be the temperature of the bearing should be less than 75 degrees Celsius, and that is the recommended principle in the industry, to have the temperatures of bearings less than 75 degrees Celsius. That has to maintain. To maintain such a temperature, it of course has to be monitored always, and RTDs and thermocouples are installed around the bearings of the fans, compressors, and the blowers. And another very important parameter which has to be always measured is also the rotational speed, which I will come later on when I talk about the vibration. But then another most important thing is the pressure. If there is a pressure loss in the line, okay, we have to look into the why there is loss in pressure loss, and many times you would have seen in the industries, shop floors, compressed air is used for all pneumatic tools, like spanners, screwdrivers, etc., are driven by pneumatic tools. Then we have for cleaning, for painting, etc. So, many auxiliary plant operations are using compressed air, and they usually have a compressed air line, okay, on out of which this coil kind of things are coming, and they are handheld nozzles. They will be handheld nozzles, okay. And whenever there is a fall in pressure beyond a certain line, and these compressors are actually regulated by a pressure switch. So, when the pressure drops below a certain level, the circuit will enable the compressor to start operating again, and then store in compressed air, usually in a large reservoir. And of course, these are designed for a particular pressure. So, as a precaution, these compressed air cylinders or reservoirs should not be able to store pressures higher than they are designed for, and that is why this pressure regulator switch is very important. Okay. So, these pressure sensors are basically, if they are static, we can have the Bourdon tube pressure gauge, for real time pressure monitoring. use what is known as the piezoelectric pressure gauges. Okay. Now, another very important parameter is this vibration. So, what are the sources of vibration in a fan, blower or compressor? Because some of them are very high speed rotordynamic devices, and because of any amount of unbalance will give rise to vibrations. Now, how does unbalance occur in the first place? If a plant is new, you saw this case of the ID or FD fan, which are exposed to the flue gases. So, many times what happens, the ash gets deposited on the blades, fan blades. And mind you, over the years, because these ash, they could be sometimes with the moisture, they could be wet and they will form like a sludge. Okay, this is the ash sludge which gets deposited, and then it creates an unbalance in the fan. And I have seen many times in the power plants, particularly because of these getting neglected in the very first day, because they think it is a new plant, what would go wrong with the fan is okay, behaving okay. But what happens is the fans, because of such uneven distribution of the masses, first of all the stresses become high. Okay. Many times failure, cracks occur, cracks at hub roots, okay. And then unbalance, this leads to a vibration. And mind you, if all of these goes unnoticed, they will eventually affect the bearings, because these sets of impellers can be either overhang or they could be supported in the center. This kind of a scenario. Or many times they are overhanged. Okay. Now, this could be your blades. And this is the origin of vibration. One is unbalance because of deposits, unbalance because of manufacturing defects can happen, and of course, leads to bearing defect, and this will lead to mechanical failure. Usually, the problem with such IDFD fans is because they are outside the plant machinery unit, they are outside the shop area, they are somewhere very close to the chimney, base of the chimney, and nobody actually periodically monitors them. And I have seen in many thermal power plants, suddenly an FD fan bearing broke, excessive vibrations from the FD fan, the blade of an FD fan is missing. These are scenarios which one has come across in the industry. And why this happened was nobody really noticed it. But nowadays with the advanced instrumentation, online automated instrumentation, wherein we have permanently mounted vibration sensors on these compressors or fans or blowers, both for temperature and vibration. So, these levels can be monitored, and of course, algorithms are there which will take corrective measures in terms of shutting down the machinery or giving you enough alarm as to something is wrong with this system, and then they need to be taken care of. Now, associated with vibration obviously is noise, but nobody uses noise as a condition monitoring tool for fans, blowers and compressors, but they definitely at high speeds these axial flow compressors and particularly the roots blowers are very noisy because of the positive displacement nature and opening and closing of the valves, and at very high speeds these create problem and they rotate. These lobes are at very close tolerance. Okay. So, it is not to be alarmed that because of high noise there is something wrong with the system, but these roots blowers, positive displacement compressors, they are very noisy. Okay. Many of the material handling equipment in plant, they also rely on compressed air line to transport soft items, conveyors, pneumatic conveyors. In many plants, these pneumatic conveyors or compressed air lines are used for conveying things. Okay. And another very important parameter nowadays, all these compressors or the fans, blowers, who is driving them? The prime mover in all the cases is usually an induction motor. Usually in such systems we do not have a gearbox. So, basically this is a motor and then there is a coupling and then there is a fan unit, which could be a axial flow fan, could be a centrifugal blower, or so on. Now, usually there is no gearbox and this is actually a coupling and they are put on their respective foundations. Okay. And they are nicely anchored, because some of these motors could be as high as 1000 horsepower, particularly in steel plants where we require such high pressure air to be fed to the blowers for combustion. They have very high power motor, and if these motors and the centrifugal blowers, of course, they are not in perfect alignment, there will be a misalignment. So, all the problems associated with rotating machines which we have studied so far in terms of unbalance, looseness, misalignment, foundation bolt loose, okay, they all manifest as vibrations. But apart from vibrations, we can also, because see what happens, because if there is a defect in this vanes, it is going to give a, and this defect, say for example unbalance. So, this unbalance is going to create a sinusoidal variation in the force, torque, vibration level. So, this kind of variations do come as a load torque onto the motor. So, because of this load torque, the current drawn by the motor also changes and it gets it gets current becomes amplitude modulated. So, I had told you about this motor current signature analysis, or maybe we will study in few of the classes, previous lectures on motor current signature analysis. So, MCSCA can also be used to monitor the defects in the fans, blowers and compressors. But from the vibration spectrum, so we can also find out the characteristics of all these fans, blowers and compressors is what is known as the fan vane pass frequency, or what is known as the blade pass frequency. Which is nothing but number of vanes or blades times the rotational speed. So, for example, if there are 20 vanes and the fan was running at 1200 rpm. So, this is 1200 by 60. So, this is close to 2400 hertz. So, in the vibration spectrum, I will definitely see peaks at this corresponds to how much 20 hertz. I will see peaks at 20 hertz, 40 hertz, maybe 60 hertz, and of course, all the way. So, this is 20, or which is known as 1x, 2x, 3x, and then of course, 400 hertz. This is the vane pass frequency, some vibration amplitude. Okay. So, the occurrence of this vane pass frequencies and sometimes side bands around these vane pass frequencies indicate the condition of the compressor. So, we talked about an ISO standard depending on the power of the machine, in this case the machine being a fan, a blower or a compressor. There are limits as to what is the maximum amount of vibration level which can be withstood by such a machinery. But this does not tell us what is wrong with this vane pass frequency or what is wrong with this fan, blower or compressor. So, if we do a detailed diagnosis, usually by vibration monitoring, we will find out this vane pass frequencies and side bands around the vane pass frequency, and there will be change in the vane pass frequency, number of blades change, and all the theory behind the vibration monitoring which we have discussed earlier as to where to put the vibration sensors in the case of fans, blowers or compressors. We can still use the bearing housings. Now, if the bearing housings are not accessible, we can come close to the casing or close to the foundations, and many times people are also using a lot of laser based measurements. For measuring the torsional vibration. Okay. I can find out missing vanes, because we just mentioned about the compressor, and when we talk about the gas turbines, I will talk about multi-stage compressors. Okay. Compressors, there is usually a low pressure compressor, because as you know, as soon as you compress, the temperature will increase, okay, and we have to have an intercooler, okay, and then intermediate or a high pressure compressor, because the limits of compression also limits you to how much you can compress in a given volume or given stage. So, there are multi-stage compressors particularly in the gas turbines. Okay. These are the compressors, and then of course, you have the combustion system, and then we have the turbines. Okay. So, the compressor and turbine, particularly in an aircraft engine. When we talk about turbines, I will talk about this aircraft engine compressors, and then we have the combustion system. Now, in such a case, because the temperatures are very high, one has to be careful as to how to monitor the vibrations, and so high temperature vibration monitoring is a special application for particularly for gas turbines. Of course, nowadays there are accelerometers available which can measure charge type close to about 600 degrees Celsius, but beyond that we cannot possibly measure vibrations through contact type accelerometers, but then we have to go for the non contact type laser based systems. Of course, there are many challenges in condition monitoring of fans, blowers, compressors, particularly for high pressure and high temperature applications, aircraft engines. There are challenges, and whether to monitor vibration or whether the reliability, robustness of the measurement systems such high temperatures and pressures also play a major role. Simple plant level IDFD fans, AHU blowers, they are very standard. They are very easy to monitor and diagnose. We can put an accelerometer on the bearing housings, measure the vibrations level, do an FFT, find out the spectrum, find out the vane pass frequencies. That's pretty good. But think of an aircraft engine, or think of an such a gas turbine unit used for marine propulsion systems. When you talk about gas turbines at such high temperatures, there are challenges as to can vibration monitoring be made. What about rubs? What if the compressor vanes try to touch the casing? What if they foul with the stator blades? So, there are very serious issues to detection of rubs in compressors, detection of the misalignment in such stages of compressors. Kind of in many compressors, imagine one blade is imperfectly fit or has a small amount of unbalance. We are talking about speeds of 30,000 RPM. Such high rotational speeds, you will see that the unbalance forces are so high that they can have determinant effect on the bearings. Again, what type of bearings do we need, particularly in land based systems? We can have because the rotor weights are itself so high, we need to have hydrodynamic bearings. Okay, and what are the stability issues of hydrodynamic bearings in terms of the temperature, in terms of the oil viscosity? Okay, and these are serious issues which need to be looked into. So, what are the essential components which we can monitor in a compressor or even in a blower. Of course, the bearing, and bearing means bearing temperature and vibration, and a very essential important point in this compressor or air, particularly when we are handling gases which should not interfere with the system, we have to design of certain seals. Okay. We have to design of certain seals which are made to rotate with the shaft, okay, so that they do not come in contact. Okay. So, and these actually press against the surface with a spring. So, seals are there, okay, to avoid a leakage. So, the seal leakage is a particularly when we are doing gas monitoring or sorry, not gas compression. So, many special features are there, whether the seals have worn out. If seals wear out, we will have wear debris collected in the casing, and then blades could be cracked, unbalanced, missing, casings can be cracked. So, then we can use NDT techniques. So, these are some of the techniques by which these machineries can be monitored. These are the components: bearing, seals, blades, and casing cracks. Okay. Thank you.